Hey, hello everyone. What's up? How are you guys doing? I'm back with yet another video. Yesterday I couldn't come live because I got some injury in the gym and then I had to take rest, I guess. Today I'm back, so let's get started and let's see how you can do image manipulation. We'll be doing it in a very simple way, nothing very complex. So let's go to the guest account. Yeah, cool. So what we'll do, the first thing, why do I click? I hate this feature of so let's go to the item and let's actually create a new project and let's start from there. Let's go to projects and let's create a new folder and let's call it what? Video manipulation. Yeah, let's go to video manipulation and let's see how what all things we can do and how we can actually manipulate things in a video. So the first thing what I will do is let's create a file. Let's call it index.js and let's create a index.html file. Let's call it script.js and let's do one thing, let's go to the, let's have like the default stuff. And then what we can do is we can just go below and we can delete this and we can say video manipulation. Yeah, cool. So we are done setting up things. What we can do is we can just right click this and we can say open with live server, which will open this in our very own super cool browser. So once we have the browser up and running, I guess I'm hiding a lot of code, so I can put this over here. And now this is cool. Okay, so now what we can do is we can just notification, we can link our script file. So we can say script dot src dot slash script.js, a normal HTML project, normal setup, nothing fancy. So the first thing what will start with is creating a canvas. So we'll say const canvas is equal to document dot create element canvas, and then what we can do is we can just we can say document dot body dot append child, and we can append this canvas. We'll try to do motion detection today. We'll try to do a lot of stuff. The plans are basically to do motion detection. Also, like if you guys know about image kernel, right? Awesome thing, bro. Image kernel. So we'll try all these effects as well today. We'll try the blurring, Gaussian blur, normal blur, all of those stuff. So we'll be trying this. This identity matrix is like it doesn't do anything. We'll be trying this edge detection. We'll be trying this sharpen. Box blur is very simple. Box blur is simply normalization. So we'll try this as well. Gaussian blur we'll try to do a lot of stuff. A lot of information has been provided about all these effects over here. We'll see how far we can reach. Let's see. So kind of cool. Okay, so the first thing what I'll do is I'll just append this. The problem is the canvas needs some width and height. So we can have can width of like 1080p, and we can have like a const can height. In your case, you might keep it less or more based on the resolution of your screen, but I'm keeping this much, right? And then you can say canvas dot height is equal to can height, and then canvas dot width is equal to can width, right? Cool. So we have done like the height thing, the width thing, kind of cool. Now what we can do is we can just take out the context from the canvas. So we can say ctx is equal to canvas canvas dot get context, and we can say 2D. We want a 2D context. But there are a few more other things we'll be passing, like alpha value to false. This is how you do. And frequent read. I don't remember. Frequent read HTML canvas. Let's see, what do we call like this frequent read, whatever that was. Get context attributes. So there's like something called frequent will read frequent. So alpha we have already given, and then like it's like will read frequent. So if you're dealing with any kind of video, I'll say just do this. This will be very helpful. So we'll say true. We are drawing and manipulating the same, like we are drawing into the same from the same canvas, and we are putting the data also in the same canvas. Ideally you could like if you want, you can keep a separate canvas for reading the data, and you can keep a separate canvas for writing the data. That could also be an option, but it's up to you, however you feel. Like if we also like feel like our work is not getting easier due to this, like just having single canvas, we'll also create like two canvases. It really depends on the what kind of use case do you have. Let's start with one example. Let's start with blurring, like how to blur frames. So what we'll do is I'll go to the pixels. I will download some folder. Oh, I have to verify. I'm not a robot, man. Why do you think I'm a robot? I am not a robot, right? Okay, so let's search for flower, and we need some good flowers. What the hell? Why do I see humans? I don't want humans. I want flowers. I want rose. I want a video, bro. No photos. I want videos. Oh, can I have flowers? Yeah. No, I want videos. I told you, right? So this is a video, right? No, it's not a video. Yeah, these are the videos. Oh, this is looking cool. These are also looking cool. Should I try this one? Should I try which one? Which one should I go with? That's the question. All of them are looking pretty. I mean, yeah. So yes, let's go over here. Let's start with this rose one. This is looking pretty. This video is kind of cool. There's a lot of things changing and stuff like that. Uh, hmm. I never thought I'll take so much time in selecting one. Oh, this is also looking good. Hmm. This is kind of boring. It's already blurred. I mean, what will I blur in this? Uh, can we have something great? I think this looks really awesome. Really have a subject in this, and there are various kinds of things, so it will give us a good perspective. But still not sure which video should be used. Oh, this is great. Oh, this is great. Let's download this. Yeah, I'm gonna download that, and let's put it in the where should we put it? Let's put it directly in the this file. So let's call it video.mp4. Yeah, kind of cool. Okay, so now we have video.mp4, and what we have to do is we have to play this video.mp4 in the canvas, not inside a video tag. So for that we'll have to write some controls. So let's write some controls now. What do you say? So controls. Okay, so these are the controls. Const play button. Right now we only want one, so document dot create element again. Play but not plain text button. Then we can say play button dot inner text play video, and then we can have like document dot body dot append play button. Well, so we have a play button over here, and then we can do like this. We can select play button, and we can get rid of this one. Yeah, kind of cool. Where is the play button? Oh, this is like append doesn't work like this. You have to say append, and then this goes over here. What if like we just uh, place it before this stuff? I mean, I want append to be on the top. Why is it in the? This is funny. Okay, we don't care. When we click play, it should play the video. That's all what we care about, right? So then what do we want to do is we want to get like the video tag over here. So I would really want to get the video tag. So I'll just say const video is equal to canvas dot not canvas document dot create element. I will call it video. See, there's a tag for image, right? So there's like special object for images and all, but there's no special object for a video in JavaScript, right? As far as I know. So yeah, we'll have to manage by creating an HTML, and we'll never be showing it actually on the screen. It will be just for internal stuff so that we can draw it on the canvas, and we don't have to like care about unpacking and processing all those stuff. Yeah. So then what we can do is we can just simply say video dot width is equal to whatever the can width is, and then video dot height is equal to can height. And then what we can do is we can just say video dot src is equal to dot slash or slash or like video dot mp4, which is the file over here. Okay. And then what we can do is we can say this play button dot on click, right? What do I want to do? I want to do video dot play. These things we already did in the first part. If you haven't watched, go and watch that part. Then it's new task today. Yes, of course, we will be learning a lot of things today. So see, Rahman, basically I tried to do the okay, I'll just show you the code. Okay, I tried to do that that stuff, tracking, but I think that requires a lot of additional things which I don't know yet. So first I have to learn that. So what I did is like, should I explain it right now? Okay, what I did is that all the tracker points which I made, I was exactly you. Oh, this doesn't make sense unless I'll show you the code in some time, okay? And then that will make sense. If I'll explain it, it will be completely weird. Like very hard to understand. So just to give you a recap, like what's going on here, it's very simple. We created a button which will play the video. We created a canvas. We give it a width and height over here. In here we got the context. We set alpha false, so there's no alpha changing. We don't care about alpha, and we'll read frequently, because if you remember, we were getting that error that if you are reading very frequently from a video, from a like if you're reading the canvas very frequently, you need to write this. Okay. And then we have a video over here. So we create a video tag, and we'll be drawing this video tag inside a canvas right now. So let's do that. We'll be having an animation loop function, animation loop, right? And we'll say a request animation loop, and we'll pass this, and then we'll call it over here. So now this will do what is this will call itself again and again and again. It's like a recursive function, not recursive function, like a loop function. So it calls itself, and then we can do stuff over here which we want to do. So first of all, let's start with drawing the video on the canvas. So we can do that by simply saying ctx dot draw image, and then what we can do is we can say I want to draw the video, and then what I want to do is I want to start it from 0 0 and do till can width and can height. So this goes from 0 0 to can width can height, and let's click play video. So it starts playing the video directly on like the canvas, and this playing on the canvas. This is not on the video tag. Remember, what benefit does it bring? We can read the pixel data directly if you are doing it on a canvas. That's the biggest benefit. Okay, so now so far I think this is very clear. We were doing this already. We were doing this before, so nothing very fancy. Let's start the pixel manipulation over here, and let's start with the first effect, which is blur effect, which is the easiest effect of all of them. It's just this. So if you remember this, it's just this box blur, which you kind of like give the equal priority to all the pixel. So we'll be going with this box blur. So if you see this matrix, we are giving equal priority, and then we are like doing 1 by 16 of that, which is like divided by 16. This was not clear why this is dividing by 16, but ideally this should be divided by 9, because there are 9 elements. That's the average, but we'll see. We'll do this. Yeah. Okay, so this is the video. Great. This will restart the video. Okay, this is not playing, so I can just play this again. Yeah, this is great. Okay, so let's first get the image data. So we'll say frame data. A single frame data is equal to ctx dot get image data. Now I want it from 0 0 to can width can height. And then what I can do is, so I have all the here right now. I have all the frame data, and then what we can do is we can have like a data, and then we can say frame data dot data. That is like all the data, and then we can do the manipulation on this particular data. So this works like let I is equal to 0, I less than whatever the width is. So we'll be going all the x. First we'll be going to the depth, which is like all the rows, and then we'll be going to the columns. That's how it works. So we can do like okay, what can we do? We can do can width, right? And we can do I plus plus, and then should we do x? I think we should call it y, because this is technically the y dimension. And then we can do like let x is equal to 0, x less than can height, and it's x, right? And then x plus plus, which is yeah. So this is y dimension. Y is like the down dimension, and x is like the left, like whatever, like y is below and x is like going sideways. So basically, if you remember, this is the issue we were facing tomorrow. Just love the fact you were explaining to no one before I joined. That's dedication. That's all good. Great. It doesn't matter, right? So like people will watch this video even after I record the stuff, right? Hmm. Yeah. So whoever gets helped by this video is amazing. It's just me learning, right? And you know the best part, explaining what you are learning makes your own own knowledge very stronger. Like when you explain the things which you are doing, it's like you find your own flaws. Like, okay, where are you lacking and stuff like that. Okay, that's great. So we'll take the like if you remember how okay, so I'll just explain this. I think this is one of the biggest doubt which people have while pixel manipulation using Canvas. First is how the pixels are stored. So this like whatever data you get, what is the structure of this pixel data? Oh, this payments technique. Let's Google that thing. Uh, the main idea when take something that's hard, understand, try to clarify by explaining it. Yeah, that's true. Exactly, this is very true. Okay, so yeah, so let's actually now process a little bit like how this is happening. So what is the structure of this data? Just like the data is basically so imagine your video, right? Technically, how do you imagine your video? You imagine your video as like a rectangle, right? With like a lot of grids, like with like RGB values. The problem is data doesn't store it as a 2 by like whatever, like n into n grid. It does not store it like rows, right? No, it does not. It stores it as like a continuous array, like this the RGB value will be coming over here, RGBA value, then like whatever, like four values, and then four values of this one, then four values of this one, then four values of this one, and it will not go to second array. It will continuously push like the next array, next array. That's the thing, right? To know, so now to get the index of an array in like 1D array by using x and y as a dimension, how do you do this? Is very simple. It's not very complex. It's like you just multiply it by 4, because in every value we have 4, and then like just focus this, right? See, you're going row by row, right? So whatever, like if you're, let's say if you're in the fourth row, right, you have already completed like oh, you already, oh, it's an array, you already know. Okay, let's okay, but for others who don't know, let's say if someone is watching in the future, it's very simple. Whatever you are whatever row you are in, it's like you just multiply your y dimension with that, and whatever x you are, so whatever however far you are from the beginning, that is like your exact xy dimension in a 1D array. Okay. Okay, so basically how it is, it's you take your y dimension, you multiply it by can width, and then what you do is you just add your can width. No, you just add your x, and this is like your index in that 1D array out of like an xy. So let's extract this in a separate function, because I think we'll be using this a lot. So what we'll do is we'll extract this into a px array, which will give let's call it pi, I mean pixel index, right? So yeah, and then let's go return, and let's go over here. Cool. This will give us a py for an x and a y value. So we can say our index is basically pixel index of x comma y, and then you can do manipulation. So simply let's start with the most simple example which we already did yesterday, and then we'll be going to the blur example. Okay, so which is creating a negative of that particular video. It's very simple. What you do is basically you say data at I, which is like the red value, to 255 minus data at I, which is the red value, and let's create like several copies of this. So g value will be +1, uh, and then +2. Same goes over here. This basically inverts the color in the stuff. So it should be 1 and it should be 2. Great. So now if you say I'll play, and you'll say okay, nothing has changed, because whatever data you frame data you have, you have to put it back into the canvas. And how do you put it back in the canvas? It's very simple. You just go and you say ctx dot put image data, put image data back to the canvas. And how do you do this is you pass the frame data, right? And you say from where, like where do you want to start putting it? So I want to start from putting it from 0 0. So it's just going insane. We'll see what can we do for that. It's because of this request animation frame, I guess, because the frame rate is not matching. Yes, I think we should do it in a, we shouldn't do it like this. We should do it like set interval, and then like if we want to play this at 60 fps, we can say 1000 by 60. I think that is the issue. That should be the issue. Does this fix the issue? I don't know. Why is this happening? We are doing something wrong. So y times can width plus x. This shouldn't happen. This shouldn't happen. Why is this happening? Okay. From 0 0 to can width can height. And then we are 255 minus I. 255 minus I plus 1, and then I plus 2, which is correct. Remove request frame is not available in WebKit. I'm not sure. Let's see. Request. Oh, let's open this in Safari. So, that's true. Request web frame is not available in. Well, let's have it like that way. Does this? It should work, I guess, because it's very, very, very famous. It is working kind of. Oh, I think we just messed up like height and width. I think we are doing it opposite for some reason. Check. Can I use? Check-in. Can I use? Oh yeah, check-in. We can use that as well. Request animation frame. What? It's supported, bro. It's supported on Safari. It's supported on Edge. I guess it has support for all the major browsers. What do you mean 7? So, oh. This is just going insane. This is I, and then we pass x and a y, 4 times y. Why would this happen like this? I'm not getting it. Hold on. ctx.put frame data, and then we have the data. Okay, let's do one thing. Let's just to verify this is working. What we'll do is let's make this red, right? Let's make this completely red. We'll just go 0 and 0, and then we'll see. So it should give me a red. Yeah. So the problem is we are not doing. So I think this has something to do with the width and height. We are using width as a height somewhere. What if, like, am I passing this? Maybe I'm too old. Okay, it has it. I might have mistake. Last time I remember it wasn't. Anyways, focus now. Yeah. I mean, it was, yeah, it's very, you are not incorrect, like you are true. The value is like it has just been released, like just the last two version supports request animation frame. Like, oh, you cannot see this, right? So just the last two versions support. That's funny. Okay, so what we can do is, I think the problem is width and height. We are just messing up with width and height. Ish. What happened, bro? I plus one, and this red pixel is getting manipulated quite well, but y times, so y is depth, right? So y times can with plus x, which is absolutely correct. What do you mean? Like that's how it is. So if I do like x, if I like take I multiply 4 times whatever the y value is times the can width plus x. This is the value, right? Doesn't change anything. What do you mean? Why would it not work? Let's take a reference from the code which I wrote previously. Like that's exactly how it was. Okay, so desktop, it was canvas. Okay, if you see, this is some other code, some I was doing some random stuff, just get this particles dot draw. Oh no, this is not the project. It was video stabilization, I guess. Yes, I think the index is wrong, but I did exactly the same thing in this value. So this is the same blur program which we are making right now. Like I just tried it previously, and if you see the index, we were loading the index. How we are loading the index? So it's like through the function px, which is exactly 4 times y into canwidth plus x. Uh, 4 times y into canwidth plus x, which is exactly the same thing. And I don't think. Yes, the index is wrong. That I know. It's somehow taking the width as a height, height as a width. That's the problem. Like see, this is actually the height, and it's taking it as a width. Ah, data at I. I must be doing something really stupid. I'm just trying to find it. Can. Okay. Maybe because I'm just applying it wrong. Height, width. I'm just doing the video thing wrong. I'm pretty sure about this. No, this is correct. Width is width, and height is height. Can width, can height, get image data. I don't know where am I wrong. This is all correct, bro. Why would you do this? Data at I. Let's do no manipulation. Let's do like I plus 1. Let's go like data at I plus 2. We'll just play the video. Yeah, this plays the video correctly. But if I just do like multiply, like if I just do, it goes insane. Hmm. I am speechless. How the exact program is running correct at one place. Is it my Chrome messing up? Let's change the browser. In Safari, would it work? It's not 4, it's 3. It's 4, bro. It's 5500. I must be doing something. And this is very strange. This is the correct code, bro. This is the correct code. Ah, why would you do that to me? I'm like, there's some issue somewhere. We are using width as a height, height as a width. Just let's find it out. So here's the button, here is the canvas. We appended the canvas is correct, and then we have a width. Width is 1080, height is 720, that's correct. And then we do this, and then we just CTX, we get CTX. This is absolutely correct. Width, we just applied the width to width and height to height, and then this is the video. Then on the click, we play this, and this is the problem. What if we do X? This is stupid, but if this works, I don't know what to say. Hmm. At least this is happening for the entire screen now, which is, oh my god. Okay, okay, just shoot me now. I got the issue. This is scan height and this is scan width, bro. We are going in the second loop. How can I do this? Now if I do the manipulation, it would work. It would work. Bro, such a stupid. What are you talking? Oh, I just flipped this over here. Sorry. So now I can do the Y and like X stuff, whatever I was doing. And this is wrong because I guess we'll have to use that request animation from frame 60 FPS thing. Yeah, something like, yeah, that will have like a higher support and it will be supported everywhere, right? Set interval, and then we can say this. That's supported in more browsers. So let's do that way. And this is like 1000 divided by 60 FPS, not 0.60 but 60. Still this is unhappy. Why would this happen, bro? I don't get it. uh hmm. Put image data from 0 to put, like, do you need like width and height? I don't think so. Why is this flickering like this? Let's draw one frame every second. Let's see what happens. It's happening. See, it's happening. It's correct. It's correct. It's just we are doing it too fast. It's correct. It's happening. Okay. Great. It's happening. Will increase the frame rate. It's like, I think it should be 1000 times 60, and then it starts flickering. 1000 times 2. I think I'm getting the issue because this video is not even being loaded that for that time. Oh, got it. Because we are not playing the video. Lol, lol. 60. It's like when we play the video. Yes, yes. This is the issue. This is the issue. Okay. So what I'll do is, so let's do one thing. While it is not playing, so let's create a variable. Let's create a variable. Let's call it like let is playing is equal to false, right? So don't do anything. Is playing is equal to false, and like while we play, let's call it like is playing is equal to true, and like do any of these stuff if, like, no, do any of these stuff. So if is playing is equal to true, right? So okay, no, not this one. I mean this one. Yeah. So it will be all blank and good. And when we play the video, it will play the video. Great. Now we'll be blurring the video. Okay, ready? So we'll be first going doing with the box blur. This one, the box blur, whatever, like this one, the box blur. Where's the box blur? This one is the box blur. We'll be doing that first. So let's start with that. So let's render it first how it is like the original video. Let's render it like that. So what we'll do is we'll just get rid of all of these things. So again, I would like whoever is watching right now, I would like you to understand how this is working and then basically go for the implementation. Otherwise, it doesn't make sense, right? You'll just see it and just that's it. Like you don't do that. So whatever we are doing it is just watch this. Okay, I'll just be doing on the Excalibur. So this is working like this. What we do is we just have like an we just have a pixel grid, right? So imagine a pixel grid. Hey bro, thanks a lot. So I'm your favorite teacher. So imagine this is a pixel grid, right? I'm sorry if I'm taking too long to make this, but yeah. So imagine this is a pixel grid, right? Imagine this is like in the entire screen. How this works is basically you go and you like for this particular pixel, what I do is I just ideally you should go up and down, which we'll do in a while. But first, let's see this solution. You go whatever pixel you want, like 4 pixel or 5 pixel, like to the left and to the right as well. So you just average out the red value, the blue value, the green value for all the pixel from here, this one, this one, this one, this one, whatever you want. Like it depends on what do you want, like how much blur do you want. So like your that what grid is as big as whatever the blur amount you want. So if you wanted like a very less blur, keep it 3. If you want like a very large blur, keep it 12, and so on. So what we can do is we can just we can call we can have a variable over here. We can call it let blur level. Okay, blur level. Let's start with a very simple like 12 level blur, right? So 12 blur. So now we'll be averaging the red, blue, green value in 12 by 12 grid throughout the video, right? So yeah, watch this carefully. So what we'll do is we'll just say we will be just saying for let I is equal to 0, I less than what, I less than 12, right? So it's like blur level I plus plus, and then we'll do the same. This will create a black banding in the end. Of course, we'll get to the reason why it is happening, but we'll just come for J value, and this is J less than blur level, and then J plus plus, and then what we'll do is we'll just go for we'll just okay. So now we need index for all the corresponding values, right? So like all those like pixel values. So you can say what should we name this? We should like name this like pixel value is equal to pixel index of for the I which is below, which is x, so it should y, right? So it's like I plus y, and it should be j plus x. If this is not clear, comment down below, I'll explain you. But if this is clear, congratulations, you're smart. So p is the point of all the pixels, like here, of all the pixels, like in like whatever 12 by 12 grid around that particular, around this guy. So yeah, so now what we'll do is we'll say p at so we'll take okay. So now what we have to do is we have to take like r val, which is red value, which will be initially 0, green val, which is green value, which is again initially 0, and b val, which is blue value, which is again 0. Then what we can do is we can just say r val, which is red value, and then we can say plus equal to, we'll add it, p at okay, at p at 0, like so we'll say data at p. Okay, we need 3 of these. for gval, what we can do is we can just say p plus 1, and then for can you go back, bro? Can you go back? Thank you. So we'll just say for blue value, this will be p plus 2. So this will add all the values. And now to average out, what we can do is we can go over here and we can say the date. Okay, so now we have to take the data at xy. So like the point at xy. So let's name it like what point p? What should we name it? Frame point fp, right? Is equal to px of pi, pixel index of x and a y. Simple. This is simple. This is simple. And then we can say frame. We can say data at fp, which is like, yeah, data at fp is equal to, no, wait, hold on, is equal to r val. So whatever the r value is divided by, because we are running this particular. So if let's say there is like 12 grid, right? 12 grid. So you're doing like 12 by 12. That means the total amount of grid is 12 times 12, which is 144. So that's what we are doing over here. So let's go here. Yeah. So it is 12 times 12. So it will divided by mat.power. I could have done like 10 that times that, but let's do it this way. I mean, yeah. So let's like take the blur level and let's give it like 2 power. So yeah, we have to do the same thing 3 times. One for like fp, and then one for fp plus 1, which will be g rg, and then this will be b, and this will be this should significantly blur the entire video. Let's see. Our video is blurred, but there's something wrong. It's very slow. It's definitely very slow, and the video is blurred. But again, that same red height issue is happening, I guess. Let's decrease the blur level. I think having it 3 will like significantly improve the performance. Yeah, it definitely blurred it. Oh, we have done something very weird. So we say like I plus y and j plus x. I is like the bottom thing, is I plus y, and j plus x, which is correct. And then we take f plus, we say fp is equal to r val divided by nothing works for the first time. Nothing works for the first time. We'll have to see what is the issue now. So so this is I, which is okay. So whatever the value of x is, let's think of this like this. Whatever the value of x is, first where I don't know, plus I, and whatever the value of y is, plus j. Doesn't make any difference, I guess. Oh, now it is correct. So you can see the image is slightly blurred, and now it worked. So let's increase the blur level. Of course, let's decrease the frame rate. So let's have like a 30 fps. We'll be doing this like less amount of time so that our performance would increase. So now what we can do is we can just have like a we can increase the blur level. So let's say blur level is 12 now. What happens? Oh, we have successfully blurred the image. Does that mean I want some celebrations? Come on, some celebrations. We have blurred the image. Of course, this is very slow because yeah, let's make it like 20 fps. 20 fps the video will be really choppy, but you can see the video is blurred. Let's try the full 60 fps. Like, how does it happen? It's like very hard to will it even work at 60 fps? It's barely managing. I guess if we just decrease the resolution, it would work. So if we make it like yeah, we finally made it blurred. We'll be going with other kind of stuff as well, but yeah. 540 and what is like this video? 360. Let's make it like the video smaller so that Yeah, so that we'll just zoom it out so that our video could be like playing a little bit more faster. So like it depends on the however less your video resolution will be in the beginning, the more blurred your image will be. So you can see the video is blurred. Great. So we have successful. Okay, who wants to save this video? Okay, can we? What do you want? Like, just tell me. Okay. So what do you want? Should we go for like? So this is the box blur. We should go with other image kernels, or should we work on saving this video to our disk? Like whatever we do, we can save it. Like we can download that. Something like that. What is more exciting? By the way, there was Game of Life, which was very interesting. I'll just show you one of the code which I recently saw. It was amazing. Like it is really amazing. So I'm not sure I have seen the. I'll just go for Game of Life JavaScript. I'm not sure where did I saw it. Not this one. Yeah, this one. So, but the video. The video is really good. You can definitely watch. But right now, I will just show you the JS implementation of this. So where is the JavaScript implementation? Yeah, so this is the JavaScript implementation. What I'll do is I'll just copy this entire file. I'll paste it in my HTML. Okay. Oh, save it. Of course, we'll do that. Sure. So why I am showing you this, I'll just give you a context because the code to save it is actually here. So we'll just make sense of that thing. But before that, I just want to show you what this is. This is quite amazing. So this code, which I just copy pasted from this particular Git repository. I'll just refresh this. Okay. It's just confused what happened with this. Oh, this is his version of. Oh, this is not what I was expecting, bro. Oh yeah, so this is very interesting. So this simulates life. Okay, so with a bunch of random particles in 3D space, this kind of simulates like a normal interaction, and you can manipulate a lot of stuff from here, from the side. I know I'm here, but I'll just move myself somewhere else, and you can see, you can manipulate stuff, and it's really amazing. And why I'm excited for this is because there's a code to basically save the whatever this is. Not sure did I saw this code. Uh, it was not exactly this. It was a little different. Let me see. Was I seeing this? Here's a live example. But forget it. Let's do the research and let's see can we manage to save this as a video, as an MP4 video in our. But this is really good, right? Like this stuff. We'll definitely see how this works someday. Will saving the video frame bypass the DRM? Just wondering. Hmm. What is DRM? I guess it will not. I guess it will not. Yeah, but if you manipulate it, ultimately you can because the video is changed. But it should look inspired. It should not look copied. That's my take. I'm not sure. We'll have to do more research on copyright. So let's get it back to how it was, like our own code. That's script.js. Cool. So now let's try to save the video. So what we'll do is there's something called a recorder. Let's do a little bit of research how to save canvas as MP4. People must have done this, right? People must have done this. Oh, he has a code. So he's using something called ffmpeg. But the problem is this is a Node.js demo. Oh, but he is just importing this as a script. And then what he's doing is he is but where the canvas thing came? Wait, hold on. So you load ffmpeg, you say ffmpeg.write with cam data. That's not what we want to do. How did this guy did it? The source code is in the repository. So there's something called capture stream, which is quite cool. Okay, so Canvas has something called capture stream, and then you can just there's a media recorder. You can pass the stream, and then you can type, like, you can give it a name, and then this will give you the data chunks. Media recorder dot onstop. Yeah, start recording using one. Yeah, that's cool. And then when they stop it, then you have a blob. Then you just uh, blob, and then you create a link, and then you say, this is fascinating, this is cool, let's try to implement this one. The solution I really liked, like this is what I would like to do. Okay, so for this we would need few more buttons. So let's quickly create them. So we'll call it start recording button, document dot create element, this button, and then let's say start recording dot inner text is equal to start recording, and then we can have a stop recording button. Stop recording is equal to document dot create element, and let's call it stop recording, or like button, uh, and then we can call it stop recording. Then we can say inner text, and then we can say stop recording. Okay, and then let's append all of these. So canvas, we can say play button, start recording, stop recording, and so on. Yeah, kind of cool. So we should have several buttons now. So we have start recording, stop recording, all those buttons. Now what we can do is we can just cool. So we can even have a status. We can have a status. Yes, let's create one more element. Call it like const status is equal to document dot create element, and this will be a normal h3 element. Then we'll say status dot status dot, what do you mean, recording status, and then we can say recording status dot inner text is equal to not recording, because it's not recording in the beginning, right? Great. Now what we can do is we can just say whenever you start recording, it will create a stream and it will start adding the data chunks. Yeah, it will start doing that. So let's go to the end now, and let's call it like whenever you say start recording dot on click, and then what we can do is we can just say this thing which this guy is telling us. It says create a thing called chunks. Okay, we create like chunks in this, and then we say media recorder is equal to new media recorder, and then what you say is you give it a canvas stream, and then you get that stream from where? That's the question. Hmm. It's just told me capture stream. So you have chunks, and then you have stream. Can stream is equal to canvas dot capture. Well, saving, okay, capture stream, and then we can save it as 30 fps. That works for me. And I said this dot media recorder. We are already doing this over here, and we can pass this can stream to that, and then we can say the file type, which is this is video slash web m, and then let's use the same codec is equal to vp9. uh, this is amazing. This is not a different thing, so this is like the same thing inside this array. So this is the mem type, I think that's what it is called. And then using this media recorder, we can record the camera stream, which is kind of cool. So now, whenever there is like, whenever in the media recorder, there is data available, this event, and then we'll say chunks dot push event dot data. Cool. Makes sense. And then we can say whenever it stops, so you can say media recorder dot on stop media recorder chunks. Okay. Handle media download. Let's call it this. And let's create a function for this. Function handle media download. And can we do this? We just did this, and now I think that's what it's doing. That's what it's doing. Chunks we already have, and start recording using 1 second time lapse. That is, data is available every 1 second. So yeah, that's good. So whenever we want to do this, only once the button is clicked, so we can say this dot. No, this not this dot, but start whatever start recording dot on click. You can say whenever this is clicked. Oh, I have already this. Okay, so you can say okay. What we can say is we can just say media recorder dot start with 1000, which is like every 1 second the data will be available, which is cool. And then we can say handle media download. So we can just say stop recording dot on click is media recorder dot stop that, and then we can say on stop handle whatever that thing is. And then this is the very interesting part. This is the best part, I think. We create an anchor element, right? So we say we basically create a blob of that entire video data, which is like a new blob, and then we pass the chunks, and then we say the type is again the same, video slash webm. Cool. And then what do we do? We just chunks, not chunks. This is insane. CHUNKS. Copy this and paste this over here. Same goes here. Okay. Now what do we do is we just create an anchor element. It's a document dot create element A, and then we say A dot style. Oh, it didn't need the style. Okay, we didn't. Okay. A dot style. Oh, we do need to do it. I don't know that. Display none. Cool. And then we say A dot href is equal to recording URL, which you create by doing create object URL. So let URL is equal to, you can say URL create object URL blob. And then what we do is this, we just say this is the URL we have to go for download. Not sure if the styling is required or not. We'll see whether this is required or not. We'll modify this code, whatever this guy suggests, after we are having the basic version of stuff. So we can say A dot download. A dot download is equal to video dot webm, which is the name of the video, and then then document dot body dot append append child, this particular guy, and then we can say A dot click clean up. Then it uses something like in a timeout. It says, I really don't get it why it is in timeout, but it says just watch some Stack Overflow page, which we will. But first, let's revoke URL, and then we can say URL. Should work technically. Let's see. Time for the truth. How many of you are still here? I don't know. I'll have to see how many of you are still watching. So we'll play the video. We'll start recording. Wait for 2 seconds, and we'll stop recording. Let's see, do we? Oh, we this does work, bro. This does work. Can you see? Oh, we did it! We did it! It's a video getting saved of the exact same dimensions, bro. See, we just made like a 30 FPS video blurring thing. What do you feel? What do you feel, guys? What do you feel? I know this is terrible, terrible web frame, like terrible frame rate, and it's not looking very pretty, but we have something, right? We can download a video. I'll explain the situation. I'll explain the code, of course. And then ask like why. Okay. Same principle as the solution above, but I have the issue with Firefox Photo where large files like more than 50 MB are truncated at random positions. Rescheduling the call for revoke object URL fixes the issue. So this is a Firefox specific issue due to which we have to do it in a set timeout. Okay, forget it. What the main solution is, it's very simple. Canvas gives you a stream. Yeah, high five. Oh, you're still here. Did you saw Rahman? We just downloaded the video. I think the mission is successful, and I'll be explaining the code. If you already got the code, amazing. But if you didn't got the code, this is how it works. So whenever you click start recording, we just say media.start recording. And why this 1000 is there is we want the data to be available every 1000 milliseconds, which is 1 second. So it will be like we do not want like instantly as soon as the data is available, because yeah, so that we don't have that array, like whatever chunks array we have, it doesn't grow like very large, right? So we just push it every 1000 seconds. Then what do we do is we just look at this particular place. This is very interesting place. Okay, we have a chunks array which has the data chunk. I got it for the audience later. Yeah, let's explain it for the audience over there. So chunks is basically all the data chunks, small data chunks, and then we create a stream. So if you haven't worked with stream, stream is very simple. Stream is like just something. It's like you did get the data continuously after like in a certain duration, right? So it like as soon as the data is available, you get it. But for now, we have set the duration to 1 second over here. So then what we do is we have the on data available, like as soon as the data is available, it pushes the data to chunks. So all the data is right now will be like there in this chunks array. Once you click stop, it will take the chunk array, create a blob out of it. How is that happening? This is how it's happening. You just give the chunks and you say what is the type of this blob. Then you create a download URL, right? So this like creates a base64 URL of your entire data. And then what you do is you make an anchor tag. I feel this is not required. Let's try. I feel this is not at all required. Neither this is required. So it will still work. I think at least. Let's see. Where is my video? Yeah, I feel it will still work. Start recording. 1, 2, 3, 4. Stop recording. Yeah, it works. See, I told you, no? Right? It will direct it. We do no need to mount it in the browser. It still works. So yeah, the same video. It still works. But yeah, this is how it works. Very simple. And we're thinking why this? Because if you have a very large blob size in Firefox and in Fluid browser, as you saw in this guy is explaining. Where's that post? So basically, if in browser it is more than 50 megapixel, it like truncated, truncated, and then the download does not happen properly, which you don't want to happen. So you just revoke it every time you do it. Okay, cool. And audio tracks. What do you do? This is funny. We do not preserve. Okay, but okay, here. Okay, so we do not preserve the audio, but we don't have an audio, right? We are doing manipulation. We should take the audio from the video and put it back in the audio, but we'll be doing this later on. That is going to be a little complex. Great. So now what should we try? We have tried two things. First is blurring the image. Second is we have tried downloading the image. We did both of them, right? Not downloaded, downloading the video, not image. What should we try next? Any recommendations? Any recommendations? Let's try now some other image kernels. That would be cool. Let's try maybe uh, hmm. Let's try this refine or edge detection, something like that. This looks very cool. I don't know what will happen, but let's try. Who cares? So what we'll do is we'll just let's have this. Let's call it refine array, and let's have this whatever this particular thing, which is 0 minus 1, 0 negative 1, and 0. And then what we can do is we can just say negative 1 5 minus 1, and then what we can do is we can just say 0 minus 1 0. This is the refine array, and we'll be using this right now. So right now here what we need to do is let's go to like let's keep it 3, and then what we can do is we can say, what do we multiply it? Okay, I think we do multiply it. So we can multiply by whatever the what was the name of that particular refine array. So we can call it like a refine array at ij, and we just have to do the same for all of them. Copy, paste, uh, paste, and we do not have to work around with this averaging thing, I guess. No, that is not our concern anymore. I don't know what this even will do to my video. Whoa, bro, it did something. It's like the edges are very vibrant now. Yeah, it did something. I don't know you can notice or not, but it is not what we were expecting, I guess. Uh, hmm, it's very let's increase the pixel size. I mean, uh, let's increase it to like 1080p by 720. Let's reset the zoom. Let's start playing the video. I think sharpen. Okay, let's try the sharpen one. Yeah, that's that I was okay. Sharpen one. Let's try the sharpen one. How does it look? It is like based on the Gaussian blur with amount 1 and threshold 0. Oh, this one. Okay, let's try this one. So the array which we have is 0, negative 1, 0. That's correct. And then again negative 1, 5 minus 1, and then 0 minus 1, 0. That's a sharp one. Okay, we get. Did it actually work? Uh, and then it does not have anything to divide with it. Should work directly. Oh, bro, it worked. I don't know you can feel the difference or not. It's very hard, but it worked. The image is definitely sharper now. I mean, let's try not putting it to the screen. Let's see the difference. So like if we play it like this, it is like this, and then if we just put it like that, uh, can you see these places? These just look at these places, like these places. We should, I don't know, but can we have this pixel array bigger? Uh, yeah, let's have it like hmm. Can you see these leaves? You can see the difference, right? See these leaves. It did sharpen the video. It's kind of cool. Let's try other stuff. Let's try. What do you want to try next? What should we go with? Should we go with like? Let's go with edge detection. What do you say? Let's go with edge detection. Let's see what does it do. So it will do like a -1, -1, -1, and -1, -1. Hey Robert. Hello. Thanks again, Robert. Thanks. You're amazing. This will be what my 5th super chat. I know this is not a super chat. This is called something else. But hey, hi. Okay, so let's make it 8 now. Thanks. Yeah. We have refined. I don't know. It should look like this. It should look like this guy, this rabbit guy, black guy. Yeah. Oh my god! Bro, we did it! Edge detection. Can we have some claps? Can we have? We did it. See, this is the. We are detecting all the edges, bro. This is cool. We are doing this is not refine array anymore. This should be like edge array, but forget about the variable name. See the effect. We are able to apply. We did like blur. We did like yeah. Can we have some claps? Can we have some claps? I mean, I deserve it. This is so cool. I love it. Okay, this did work. Let's try other stuff. Let's try other kernels. So we have tried sharpen. We have tried this one. Ah, let's try this one. Like, what if like we go with this one? How will that be? So like we go to 0. We do like 0 again over here. We go 0 again over here. And let's see what difference does it give us. That's funny. Yeah, cool. So we have -1, -1, and this what will this do now? Excited. Oh, I think there was some division which we are not doing. It is 4. So okay. Oh, it's 4. We are doing 8. Okay. I'm sorry. Forgive me. Oh, it is the same thing. It is exactly working. This is how it should be. See? See, it detected the. It's like edge detection. It is like this. We had 2 versions of edge detection over here in the kernel. We ran both of them, and it's working great. Yeah, that's great, right? We did the edge detection. Should we go with other matrix as well? So we should let's go with let's try the Gaussian blur matrix. Let's see how do we get it. Like let's try the Gaussian blur matrix. So we'll call it Gaussian blur matrix. So let's call it Gaussian blur matrix, and let's get rid of all of them. Let's start with this one. 1 4 6 4 1. Let's try. Yeah, it's really impressive, and the most impressive part is you can save the video that we already did, and you can do it in HTML canvas. We are not using any fancy, like, zero third-party library used. Zero, absolutely zero. That's amazing. So 4 16 24 16 4 and then you have like 6 24 36 24 and then 6, and then we can have like 4 16 24 16 4, and then I think the same thing, 1 4 6 4 1. So there's a topic in maths called gradient descent, right? So all these image kernels are basically based on that. Gradient descent is like you descend but with a gradient. It's exactly what its name suggests. We'll be doing some math stuff someday if we get like enough. Yeah, if you guys are interested in maths, I don't know. Yeah, This is cool. So now this is what, 1, 2, 3, 4, 5, a 5 by 5 array, right? So this wouldn't work. Like this wouldn't work. Would this work? Oh, this would definitely work. Okay, let's try a Gaussian blur now. The problem is this variable should be here. Gosh, where's the where's the damn? Oh, this should be here, right? And now the blur level will not be 3, it will be 5 because it's 5 by 5 array. And we are definitely going with some division in the kernel if you see. So it is divided by 256. So let's divide all of the values by 256. Same goes with this one. Divide by 256 and divide by 256. Cool stuff. And let's now see the result. Refresh this and say play. It's blurred, bro. It's blurred. It's very slightly blurred because the pixel array size is only 5 by 5. Like for 12 or let's decrease the size of the image, and this will be more prominent. So if I like do 540 by something like 540 by like 360, you'll be able to now see it, I guess. So yeah, let's make it like a little bit zoomed. Play the video. Yeah, you can see the blurred, right? It is blurred, and it is blurred in like that like Gaussian fashion, which is not you know the difference between normal blur and Gaussian blur, right? So it's different. Yeah, cool. uh it is teaching about convolutional all those stuff. We already did this is cool stuff. What's next? I think we have we have already covered a lot of things. What do we, oh, let's go back to that stuff. Edge detection was the coolest one, guys. Let's go back to the edge detection. Let's see that once again. That was cool. Yeah, let's do this like this. Yeah, so we'll see edge detection once more. This is too big. Yo, bro, do you want to download this? Let's try to download this video. Start recording. Now we'll just end the stop recording and we'll save the video. And let's try to play this video. Bro, we saved this damn video and now it is playing, bro. Yeah, we did it. Yeah. Anything else? I don't think so. Anything is left. We had the motion detection, right? We have to do motion detection. Okay, let's try to do. How many of you is up for a motion detection thing? We'll detect motion in a video. We'll see like it's like a CCTV security stuff. So if like something is changing, it will alert like there's someone in your CCTV footage. How many of you wants to do that? Anyone? And then we'll continue with that. This is cool. Okay. Anyone interested for motion? Oh, you are excited. Okay. Let's go for it. Motion detection. Well, it will have some graphs and it will have some new to me. Okay. Sure. Robert, just let me know what you like, what's like learning a lot. Okay. That's amazing. I'm happy you're learning a lot. I mean, I'm happy when others are happy. Like, yeah. Okay. So now let's get rid of everything over here. We'll have to, yeah, there's no processing happening right now. So we'll just save this. Simple stuff. Okay. So now, like how the motion detection will work, I'll just explain you. Okay. Listen to the explanation because this is very crucial and if you want to actually understand how this works. There's one frame, right? You have one frame and you have other frame. So let's say if there is a CCTV footage, right? Let's try to download a CCTV footage. Let's try to download a CCTV footage. That's not what I want. I want an actual CCTV footage. Is this the CCTV footage thing? Oh, this is not what I want. I want a CCTV footage. What do you mean? Sample CCTV footage. Sample CCTV footage download. What do you mean? I want to see. Yeah. Can anyone give me a video of a CCTV footage? That's not. I don't want a video of. I want a thing recording a CCTV footage. Is this cool? Like, should we do go for this one? I think we can do it for any video, but what I essentially want to explain you is what we're gonna do is we're gonna have like two frames, one frame and then the next frame, and then we're gonna calculate how much percentage or how much per pixel change happened. So what, like how much red value changed, how much green value changed, and how much the blue value changed. We're gonna store the difference of whatever that changed in a different array, and we're going to visualize it, and that visualization could give us an idea of like how much motion is happening. So let's say we can set a threshold value, like okay, because see, when wind blows or something like that happens, that also creates some motion, right? So let's say if you want to only like keep like 10% threshold value, you can get an average change throughout your frame, and if that exceeds 10 or 20% of whatever you want, you can be alerted. You can create an alert like, okay, something wrong is going on in your property, or with your CCTV camera, and you can simply take action. Yeah, let's try to do it. You got it right. One frame will be comparing the first, like we'll be we'll be comparing every frame to its previous frame, and we'll compare the difference. That's what we're gonna do. That's the main idea behind this. Okay. Enough of talk. Let's get into action. Okay. So we cannot do it for the first frame, so we'll have to do it from the second frame. Hmm. So we'll have to start from one because we cannot do it for the previous frame. Cool. So no. Okay. So we have the difference. The difference per frame should also, okay, wait, hold on. So we'll have an array. Let diff array. Let's call it diff array. So this will contain the difference, RGB value difference, and this will be a new array, and this will be an array of whatever the width is, no, whatever the height is. Dot fill, again a new array, and so initially we'll consider there's no difference whatsoever. It's the same. So then we'll fill it with an array of can width, and then we'll be filling it with. Should we take an average of RGBA and then calculate difference? That works, right? Because that is a black and white pixel difference. That works, right? Let's fill it with 0. So this is right now like what the diff is. I'll just show you, right? Diff array is basically an height times width. I don't know. It's called identity. No, it's like a 0 array, like 0 0 0 basically 720 times. So it's all zeros. You can see this is how it looks. Lots of zeros, right? So this is the difference right now. We say there's no difference right now, okay? And then what we can do is we can just say that, and we'll have to store the previous frame. So we'll say let prev frame data, and let's call it like null. So how should we go about this? We're gonna need two canvases to just compare the difference, and I'll actually show you where the difference is occurring in the frame. That's gonna be cool. Trust me, the visualization is gonna be cool. But first we'll have to figure out how we are actually doing this. So what I want to do is like, I'll just say like if the previous frame is there, like if the previous frame is not there, so if it is there, so okay, if it exists, right, and we'll say previous frame is equal to current data frame. So we'll calculate the difference for every particular pixel. So index is equal to pixel index of x and y, right? And then we'll calculate the difference. So we'll say red difference, RD, which is red difference, is the Okay, what will this? The previous one minus the new one, or the new one minus the previous one, which is like data at I minus data at no previous frame data at I, and we'll do the same for sorry, we'll do the same for G and like RG and B. So RG and B. So these frames, and then that's simply plus one, and same goes with here plus one, and we can do the same over here. We can say plus one, and then plus one. Simple stuff. Cool. So that's so that's the difference, and we have to average it out and store it in the difference array. So let's average it out. So the avg is equal to red difference plus green difference plus the blue difference divided by 3. That's the average of all the pixels. But next thing what we can do is we can just take this average and we can put it in the difference array. So we can say difference array at whatever at x comma y is equal to whatever that average is, and we just have to visualize this. In order to see this like change. To visualize this, we would need like a different canvas. Should we do like different canvas, or should we like should we like overlay? Should we create an overlay which is like so there's like every pixel, right? I think this, not sure this would work as expected or not, but we don't want to put any data, but because this is just an analysis. This, yeah, that technically should give us the difference array. So this is playing, and this should give us wherever the difference is, like in the frame itself, right? So what? Let's do one thing. Let's create another canvas. Let's create one more canvas, and let canvas 2 is equal to document dot create element canvas, and let's have all those same stuff, right? So let's whatever document dot append child, and let's call it canvas 2, and then we'll say canvas 2 dot width is equal to can width, kind of same stuff. Canvas 2 dot height is equal to can height, and then yeah, and then we can say let's call it visualization vis. That's a better name than actually having a canvas to like yeah, so it's a vis, and then we can say vis. This is our visualization, and then what we can do is we can just delete. Oh, get away, get low. Oh, get up. Okay, so now we can say is visualization context, which is like let vis ctx, which is visualization context, is equal to vis dot get context to d, and then we can pass all those same thing. Alpha, I don't know, we don't need all those things. And then what we can do is we can just start an animation loop for this, which work function any loop, stupid name for an any loop, and then we can call this function. And then what we need to do is we need to draw a rectangle. We need to create a pixel array data, and we'll have to fill it every time. So we'll say let data is equal to let frame data is equal to vis ctx dot create, now not get, it's create image data, and we have to pass like from where to where. So it's like from it's like I think it takes width and height. So like we can say can width and can height, right? So it takes a data. Okay. And then what we can do is we can just say again, we can just say like let data is equal to let data is equal to frame data dot data, and then we can just do like kind of like the same array thing. We'll paste this over here, and then what we can do is we can just say this, and then what we can do is we'll have two canvases. We should have one more canvas over here, I guess, right now. Technically should have one more canvas. Uh, hmm. uh, let's have this thing, this line in the end of our entire, yeah. And let's call it, right, we need a canvas. We need a visualization canvas as well. Not VIS CTX, but canvas. I like this. That works. Yeah. Yeah, we have one more canvas. I'm pretty sure we have one more canvas. So now what we can do is we can just go to the second canvas which we had. Where is the array we were having? Yeah, this is the array. And now what we can do is we can just go through the we can get an index through like the same function, pixel index of like x and a y, and then we can say data at I is equal to hmm, is equal to diff array at x and y, and we want to do this exact same thing for all the RGBA value. So I plus 1, I plus 2, and so on. We have to, I think, do like the alpha false thing, comma alpha false, because we don't care about alpha right now. It's just angry at me. I did something wrong. This cannot read properties of undefined reading 1 at 82. Hmm. Oh, it shouldn't be 1. Oh, okay, let's go for this. Cannot read values of undefined reading 0, which is kind of strange. Okay, let's try this for now. Like just for now, just to like test stuff. What we can do is we can just uh yeah, we can just go over here. We can say control D, and then we can pass 0 over there. So we should technically have 2 0 like that. Yeah, 2 0 blank arrays. Yeah, that's good. Uh, let's make it a little like not this one. Let's make this a little smaller. Uh, should we go like, should we decrease the resolution? Should we do that? No, we shouldn't. Okay, so let's get rid of this. I mean, so that you can see both of them. So the diff array. Now, what's the problem this has with diff array? So if I say diff array at x and y, what's this? Yeah, this crashes. It says cannot read value of 0. Cannot read value of undefined. Reading 0. So like x. How is this even possible? We are filling this, right? So diff array is basically a new array. And AVG. Is our AVG undefined? What do you mean? Like at I minus previous frame data at I, and then previous frame data at I plus 1, and then previous frame data at I plus 2. And the previous frame data is data. And this is correct. I mean, I don't know. This is correct. Let's apply a debugger over here. Let's see. Okay, forget about this, bro. Right now, do not care about this. Oh, wait. Yeah, don't care about this. Hmm. But wait, this is the entire data. Oh, I'm getting it. Hold on. This entire data, this is not, hmm. This is not that frame data. We'll have to think through this a little bit. What we are storing is all the data. Wait, hold on. Yeah, so this is correct, right? Because at once you are only getting one frame which you're drawing, which is correct. So previous frame data is absolutely correct. But why is it not like my debugger is not reaching there? Why is that the case? Oh, because we are not playing it. Oh, I'm stupid. Oh, the street. Yeah, that's correct. So AVG, what is the value of AVG? It's 0. That's absolutely correct. That should be 0. Uh, oh, that's great. So now what we can do is we can just get rid of this debugger and we can say, okay, do this only if diff at xy is like something. It's defined at least. So yeah. Can you just okay? This let's copy this to all these places. Let's see. It will be angry at me, of course, yes. And then what we can do is we can just say if we can say if diff array at x comma y no at x y is defined, then do this. But the problem is this won't work. This wouldn't work because do I need to put a question mark like this? I don't even think that's possible. Is it like okay? First thing first. This is an array, right? And it goes like from whatever xy. So if we just do not set it, like for example, let's not set this array. It should show a blank screen, blank dead black screen. That's something which it should show. Okay, let's fix this. We have an array which is a new array and this and we are filling this with again an array. Let's do this like the old traditional way. This I think this array thing is doing some kind of finicky thing. Again, we have to copy the same stuff and paste it. These two arrays. Hmm. Let's say let which is like temporary is like an empty array. I know it's getting a little confusing, but I'm just trying this to like make it work. Hold on, give me 2 more minutes, and I'll be explaining what I'm doing. So diff array dot push t. Come on. What do you mean? You cannot read properties of undefined. Why? What reading 0? Why are you reading 0, bro? At I, for x and y, for x is like whatever the x direction. Oh no. Oh no, it should be yx. I'm stupid. I'm stupid. I get it. I get it. I get that. Yeah, it's yx. It should be yx. It should be yx. Shouldn't be. It should be yx. It should not be xy. I think so. Why am I changing this individually? I don't know. Sometimes. Still okay. Cannot read properties on at 90. At 90. At 90. It cannot read properties of this. Oh, what are you? It cannot read. What are you even getting? Oh, let's put the debugger. Cool. So data is okay. Data is this user array. So it's at y is 0. So it's like this gives you this, which is okay. And now at x, which is also 0, you again get 0. That's awesome, right? Then why are you so worried? That's correct, right? There's no reason why this wouldn't work, bro. Why would this not work? It says cannot be produced of undefined reason 0 in the any loop. I think we should go with the same frame rate. That would help. Would that help? I have an idea. I have a better idea than this. Like I have a better idea than this. We shouldn't create this loop at all. Like this is a slow process. We should be a little smarter, right? We should do like all of these steps, this visualization, whatever we have. We should like cut it from here. We should paste it, whatever. We should paste it over here, and we can make it happen. Like we can. And we can just manipulate it just over here. I think because who cares? Like these are the So let's do the visualization, and it will be in that particular context right now. So const visualization data is equal to visualization context visctx dot create image data, and we can say needs a width and height, so it's like can width and can height, right? And now we have a visualization data, and then inside this what we can do is we can say vis data at hey, hi Rahul, what's up, how are you? What's up, how are you doing, and how's your life? Vis data is okay, so vis data at okay, so vis data is basically the entire data, so we can say this data at we can use the same so we can just go over here and we can use the same index, right? That also works. It's kind of insane. I should be calculating my own index. I'm just reusing the previous arrays. I was not aware about the timing. I usually stream at we did pretty amazing things today, bro. I would like recommend just watch the video after we finish the streaming. We did amazing stuff today. We just created edge detection, we created download video stuff, and right now we are creating a motion detection thing so that we can detect motion. See, right now I'll tell you, detecting is very easy. I'm just creating like I'm trying to visualize this, and the visualization would look really cool. Like detection, we can do like average out all the differences and all. That is okay, but right now I'm just trying to visualize that. So let's see. So now we have this data, so which should be of the same width and height. So this data at I is equal to diff array at x at y. This would, why do I feel this will crash again? Great, bro. So we just go over here, we just say 2, this is cool. It's not angry at us, bro. That's amazing. It's not angry at us. Okay. So now what we can do is we can just instead of yeah, we just need okay, we need to do this now. And then we need to draw this every time. So we do this, all the manipulation and stuff like that. And then we go if is playing true, then we go this, and then we just say this no, this ctx dot put image data, and I say this data comma from 0 0 stored. That should be 2. The same error, cannot read values of undefined reading 1. Please also explain why are you explain why are we doing I and I plus 1 and I plus 2 and I plus 3. Okay, I'll explain you this. Okay, listen to this. First let me stop, otherwise my browser will crash. Okay, I'll explain you. Let me drink water, okay, then I'll explain you. Bro, these I love these problems. They just take every ounce of your brain. Okay, so what we'll do is we'll just understand this, right? See, Rahul, it's for you, right? I think most of the Robert and Rahman already knows how this is working, but I'm just explaining it to you. Just take an example of 4 pixel, right? You have a really small image which only has 4 pixels. So how canvas like this stuff which where you say create image data, or like however, like where you are reading get image data, frame data, and what are this data is frame data or data. What this would give you is it would give you an array of RGBA, which is red, blue, green alpha value of all the pixel in a single array. So it's like you have a one array and you have the red value of this, which is let's call it 1 2 3 4. So you'll have red value of this, which is R1, then you'll have G value, which is G1, and then you have blue value, which is B1, and then alpha value of A1, and then you'll have R2, and so on. You're getting it, right? It's like 1D array of the entire thing. It is not an array of arrays. So when you get an index of that particular thing in this, like whatever the pixel, right? So like let's say you got an index of second, you got an index of first, right? 0, right? So when you get 0, the red value is whatever the data, or whatever the a is at 0, right? And then you want the blue, which is like the next one, which is a at what, index plus 1, which is 0 plus 1. And what is that next one, which is like that? And what is the alpha value? 0 plus 3. We are not dealing with alpha, so that we are not doing I plus 3, but that's how it works. If it was clear, just say yes, I got it. And let's fix our visualization now. 1 2, what 1 2? Yeah, it's like yeah, you do. So first R value is at 0, which is over here, index. Then the green value is after that, which is whatever is the after this, which is like green. I'm new and don't know. It's okay. It's completely okay. I mean, we all doesn't know a lot of things. It's okay. So just, I would say, like, just, start with something like, can you explain a little bit about Canvas? Really? Sure. We'll be creating a Canvas basics video, but I would explain you a little bit. So, what should I explain with this? So now we'll have a different, a basic video on Canvas. Yeah, does that work? And let's finish up this motion detection first. So we'll have a basics of Canvas, like entire basics, and then we'll cover that, because this wouldn't be finished if I start with the basics, like what we are doing right now. Does that work? Okay. So, okay, great. How should we go about this? This is a video we created before, edge detection video. Localhost port 5500 enter, and if you go to the second screen, do you do this type of work for your job? No, I don't do this kind of work. So I'm basically a full stack developer. So I do React stuff, a lot of Node.js stuff, whatnot, this kind of stuff. I don't do any pixel manipulation in my job. I do lots of React, lots of Node.js, lots of backend stuff, lots of GraphQL, lots of Express.js, and so on. Yeah. I'll just refresh myself for once, and then we'll try this again. Okay. Let's wait for a second. Let's relax for 2 minutes. I mean, yeah, let's have a chat a little bit. What is like what would you guys like to like me? Like what would you like? What would you guys like me to teach? Like, or like, discuss? Any suggestions or any topic which you are interested in? Any field, something like that. Whichever you would like to learn, just let me know. Okay, we'll be doing something from that. Let's start this again. Okay, so we have this pixel index I, and then we have pixel index I, and we are doing x and a y. I think we are storing it in a wrong way. So difference at xy is the average of RGBA value. So we just take I plus 1, I plus 2. So we just take the average of that, all of them. So this is average. So RGB, and then divide by 3 is the average, and then we say whatever is xy is the average. And oh, the problem. Okay. We have to only do it after the first iteration is finished, because before that, okay, but it still doesn't matter. All of them have zero, and it doesn't matter. It should show black at least, right? Hmm. Why doesn't it work, bro? I don't know. What if we don't do it? Like, will this still be an issue? There's no issue. It's all drawing like great. For example, like let's say just for fun, right? Just for fun. I'm doing this for fun, okay? If I just say x is more than 10 or more than 100, then let's do this t dot push, what, not 0 but 255. Otherwise let's push uh, like 0. Hmm. At 78, it doesn't matter, bro. It's something wrong we're doing. It's at x at a y. Hmm. That's an array, right? Okay, now I'm getting the issue. We're assigning it wrong, but shouldn't matter at least. Okay. Uh, just for fun, is it even working? Let's set it 255 and let's do like 0 for all these. Ooh, why is this blank? So only red value should be. Why would it be blank? I think the problem is while creating the image data. What is it? What does it do? Okay, so get image data from 0 to canvas width, canvas height. Then if we do it, oh, now this. Okay, what was this the error? I guess I think this is the error. Def at x comma y. I think this was the error. As we are reading it frequently, we have to turn on that frequent thing again for this as well. So we'll have just copy this from here